the factor and remainder theorems. When f of x is divided by ax minus b, the remainder is f of b over a. So, for example, if we divide by 2x plus 5, the remainder is f of minus 5 over 2. When f of x is divided by x minus 7, the remainder is 7, i.e. 7 over 1. And if the remainder of f of b over a is 0, that means that ax minus b is a factor, because there's no remainder. How might we use this? Here's an example. Factorise x cubed plus 7x squared minus 65x minus 231. Substituting the number 1, we get minus 288, so x minus 1 is not a factor. There's no point trying 2, because 2 isn't a factor of 231. f of 3 is minus 336, so x minus 3 is not a factor. Let's try some negative numbers. f of minus 1 is minus 160, so x plus 1 is not a factor. f of minus 3 is 0. That means x plus 3 is a factor. So what have we got so far? We've discovered that x cubed plus 7x squared minus 65x minus 231 is x plus 3 multiplied by a quadratic. We know that the first term of the quadratic will be x squared, because when we times that by x, we get x cubed. And we also know the last term will be minus 77, because minus 77 times by 3 is minus 231. So, this is what we've got so far. We have an x squared, we have a minus 77, and there's an x term in the middle which we don't yet know. Now, we need 7x squared for our cubic. We've already got 3x squared from timesing the 3 by the x squared, and therefore we need another 4x. To finish off the factorisation, we already have x plus 3. We also have x squared plus 4x minus 77, which gives us x plus 11 and x minus 7, and giving us 3 brackets times together. Example 2. f of x equals x cubed plus ax squared plus bx plus 36. When f of x is divided by x minus 4, the remainder is 20, and when f of x is divided by x plus 1, the remainder is 60. Find the values of a and b, and hence factorise f of x fully. If we work out f of 4, which has a value of 20, we discover that 64 plus 16a plus 4b plus 36 is 20, which simplifies to 4a plus b is minus 20. And similarly, when we do f of minus 1, we get minus 1 plus a minus b plus 36 equals 60, which simplifies to a minus b equals 25. We can add these equations together, and we get that 5a equals 5, and therefore a is 1. And if we substitute that value in either equation, we get b as minus 24. So we now know that the cubic is x cubed plus x squared minus 24x plus 36. To factorise it, we need to do what we did before and use the factor theorem. When we try 1, we get 14, so x minus 1 is not a factor. But when we try 2, we get 0, so x minus 2 is a factor. So we've got x cubed plus x squared minus 24x plus 36 equals x minus 2. We can work out the x squared. We can work out the minus 18. Like before, we can work out the middle term. We need 1x squared. We've already got minus 2x squared, so we need another 3x squared. So the middle term is 3x. So our final factors are x minus 2, x plus 6, and x minus 3. Thank you very much.